Welcome to the UGC lecture series. In this lecture, we are going to talk about an important concept called data mining, and in today's scenario this data mining is becoming very important in a lot of business processing and business intelligence. So, in this lecture we are going to cover and understand what is meant by data mining and why you need to do data mining, and then we are going to look at the steps in the data mining process, and then we are going to look at different models and techniques used for data mining, of which we are going to look at some decision trees, clustering techniques, and an important topic called market basket analysis. So, let us now go to the definition. Data mining can be defined like this: it is the exploration and analysis of large quantities of data in order to discover valid, novel, potentially useful and ultimately understandable patterns in data. So, look at the words valid, novel, potentially useful and ultimately understandable. For example, is given a pattern here. You have a census bureau data which is taken in all countries periodically. If the relation is ship is equal to husband, then gender is equal to male 99.6%. This is not actually a novel discovery, because this is is true, but this is just to tell you that 99.6% we do not know what happens to the rest of the 0.4%. Now, let us take each of the words in the definition and explain it in detail. What is the meaning of valid? Valid means the patterns hold in general, that is, it does not hold for only 2 or 3 cases, or it must hold a majority of the cases. And then we did not know the pattern beforehand. For example, in the previous case we knew the pattern, so that is not novel. And then finding out these novel patterns itself is not important. Can we make some decisions based on this? And before we make this decision, we should be able to interpret and understand these patterns. So, all these are very important in the definition of data mining. That is why this is different from database querying, where there you know what is that you are searching for. Here, after we get the pattern only, we will know whether what we are searching for. It is actually a novel and novel pattern that we are going to discover, which we did not know about. So, why suddenly this data mining has become very important today? First of all, the availability of large databases, because data mining technique is basically statistical technique, and when we are talking about statistical technique, we have to consider large amounts of data. So, large amounts of database are available and sitting in their computer in a large number of applications: bank, credit card, transactions of supermarkets, and so on and so forth. So many places this data is sitting. This data base volume is very high, dimensionality also is very high, because now we have started taking now online forms and lot of data is available. Dimensionality means the number of attributes are very large, and because of this it is very difficult for a human being to actually sit and go through each of these records and see whether he can find some pattern, and the data moreover grows very rapidly. Because of the availability of data and because there is storage, and data mining is actually an offline process and requires large amount of computational power that is available, and there are some off the shelf software that you can use and expertise are available. So, because of this we want to use data mining. So, where are this abundance of data? Supermarket scanners and transaction data, customer cards, credit card transactions, direct mail response, call center records in the ATM machines, demographic data is available, sensor networks available, data from cameras available, web server logs data is available, customer visit to the site, that trials are available. So, all this is data. So, there is a large amount of data, okay, because of the internet. All the data is becoming available at a central place. So, another reason for data mining becoming very popular and very much used today is because of some commercial support available. There are many data mining tools, this is just one of the tool, and database systems come with some minimum data mining tools. There are also visualization tools available, so that you can understand the patterns much better, and the actual process also they support, and there are consultants available who will do this data mining process for you. So, why today? Because of the competitive pressure. The secret of success is to know something that nobody else knows. This is very well known. In today's business, everyone gets all information at the click of a finger. So, what is it that makes your business, what is it that gives you a competitive advantage? The fact that you know some pattern that others do not know, and you can take advantage of that. So, this is an old saying, it is very much applicable today. That is, competition are there on service of price and also the facilities offered. Personalization is becoming a big thing, real time is becoming very important, security. In security, how do you use this? You look at the security incoming going and looking at the pattern that is forming which is not normal, you can find out there is some security lapse. So, these are things that, and you do not expect a human being to go through this. So, now let us look at data mining is also called as knowledge discovery, these are used synonymously. So, knowledge discovery process, there are the following steps. You have to identify the business problem first. Of course, it need not necessarily be only a business problem, it can be applied to scientific problems also. Then you have to do the data mining. After you do the data mining, you have to do the action associated with the what pattern you have, and then you have to do some evaluation and measurement, and finally, these have to be deployed and integrated into the business process. So, data mining is an important step. So, data mining steps in detail, there are many steps. One is the data pre-processing. So, you have a huge database, you do not take all the relevant fields and you must know which data set to take. The data selection becomes very important. You have to identify the target data sets and the relevant fields that you want to consider. So, the decision of you just do not put large databases whatever it is and just give it to the data mining process, that does not give you anything. So, it is the business person who with intelligence who decides on which are the fields you must consider and which is the data set you must consider. Then data cleaning becomes very important. So, there may be some data which is noise or which is due to some error it has come or because of some very rare behavior it has come. So, that has to be removed. You have to do some data transformations. You have to sometimes create common units across two databases for example, and sometimes you have to generate new fields. So, this is called as data cleaning. Then you have to construct the model and then do the model evaluation. So, this is the pre-processing and mining. So, you have the original data and then you have to do a data integration and selection from which you will get the target data. From the target data you do pre-processing. So, this is the pre-processed data. From the pre-processed data you do the model construction, and from the model construction you after you do this mining operation you get the patterns, and then you have to interpret the patterns, and then as an output of all this you get the knowledge. So, this is a very important knowledge regarding data mining. So, the selection of data is important, pre-processing is important, model construction, this is the core of data mining, and then getting out patterns, interpreting it, and finally getting the knowledge. And this knowledge should be actionable as we have already discussed. So, let us take an example application which is sports. So, this is a IBM Advanced Scout which analyzes this NBA game statistics. So, this is a software that is provided. What does it analyze? Shots blocked, who assists, and what are the fouls. So, this is IBM Advanced Scout. So, an example pattern from that is an analysis of the data from a game played between New York Knicks and Charlotte Hornets revealed that when Glenn Rice played the shooting guard position, that particular player played, he shot 5 out of 6 on jump shots, he played 83%. This pattern is very interesting because the average shooting percentage for this Charlotte Hornets during that game was 54%. So, there was something wrong, so that you can detect. So, another example application is the sky survey. Here you have 3 terabytes of image data with 2 billion sky objects, this is from the sky, and it took 6 years to get that data. So, the goal was to generate a catalog with all objects and their type, and here they used decision trees. We will see how it is used later on. So, what you are trying to do, you are having a large number of sky objects with their features, and depending upon the features you are trying to put them into classes. So, there was 94% accuracy and increase the number of faint objects classified by 300% because of the pattern, and you try to fit in that pattern. So, some of the attributes are missing also you can still fit in. So, help team of astronomers to discover 16 new high redshift quasars in 1 order of magnitude less observation time. So, they were able to look at, they were able to look for a particular pattern, and so it reduced the observation time. This is just to show you that it is possible to apply this in non-business domains also. So, now let us go into the core of what we are going to talk about, which is data mining models and techniques. What is a data mining model? That is the first question we have to answer. A data mining model is a description of a specific aspect of the data set. It produces output value for an assigned set of input values. So, the examples of data mining models are linear regression model, classification model, and clustering model. We will be covering some of these models later on. So, a data mining model can be described at 2 levels. One is the functional level. So, describes models in terms of intended use. Now, before we go to this, so it tries to classify the data or cluster the data. Now, it seems to be almost similar. What is the difference between classification and clustering? So, classification means I have given a set of data or set of let us take an image processing example, set of objects, and I am asked to classify it according, okay, this is class 1, these are big objects, these are small objects, this is medium size objects, something like that. And then given an object, I will try to put it into whichever classes near. So, you know the classes, you know the features also of the classes. Clustering means I am given just a set of data or objects or whatever it is, I do not know how it is going to be divided. Okay. So, but maybe I will be given the number of clusters I want, maybe. So, what I will do is, or depending on the threshold, if these two objects are similar, they will be put above similarity is above a particular threshold, I will put it in one class. These two, like this, I will keep on one by one, I will keep on trying to merge or split, mostly merge this. Initially, I will assume that all the things are in a separate cluster, then finally, I will get a set of clusters. So, the number of clusters formed you can specify, or you can specify the threshold beyond which similarity is acceptable and the clusters is left, depends on the data. This is typical things you want to do with data. So, that is the functional level. Representation level is how do you represent the data. So, it can be represented as a log linear model, it can be represented as a classification tree, or it can be represented as a nearest neighbor method. We will come into each of this later. So, you also have what are called as box models versus transparent models. So, black box model means I do not know what is the model that I am using, but I will get the results. Transparent means that it is available. So, before we go further, let us look at what are the types of data that you normally use for data mining. What are the types of data? So, you have databases. So, you have relational data and transactional data. Typical transactional data you can think of in a bank, or you can look at it in a supermarket. You also have spatial and temporal data, spatio-temporal observation. For example, if you want to have a database of traffic, for example, you know that this car at this point of time was in this location. So, that is the typical spatial temporal data. Then you have time series data, how a particular parameter, this is typical of medical data, where how the blood pressure changes, okay, or the sugar level changes, that can be time series data. Then you can even have text as data. You can have images, video as data, you can have mixture of all this, you can also have sequence data. So, what happens after this, what happened, the sequence that can happen, and you can have features from processing other data sources. So, data mining in fact covers a large amount of data. Now, so that is the type of data. Now, let us look at the type of variables. Now, each of these can have different type of data. So, domain is ordered and can be represented in real time. For example, age, income, these are numerical values. You cannot give a numerical order, it is a finite set without any natural ordering. For example, occupation, for example, you can be a supervisor, you can be an engineer, you can be a teacher and so on. Marital status, for example, race and so on. Ordinal domain is ordered, but absolute differences between values are known. For example, preference scale, severity of injury. So, you can order it, it is highly not so serious, very serious, serious and so on, but you do not know how to actually put values to that. So, these are three basic types of data, and you can also look at data mining techniques. I will tell you what this means, but basically there are these are the techniques that are necessary. One is supervised learning, okay, I will go into detail later, but it is given a large data set and that data set is fully already classified, and from that I try to learn a model. In unsupervised, I am not given any tag data, I am just learning, and then I do dependency modeling, very important data mining. I do outlier and trend analysis. Dependency modeling, this is very important. Here we are looking at associations between data, if this happens will this happen, summarization of data and causality, and outlier and deviation detection, and trend analysis and change detection. We will discuss some of these later. So, first let us look at supervised learning. Here what we do is this f of x is the function of x, this is x is the data, and the training the sample has been drawn from f of x. So, this is all tagged, and this is the training sample. So, you are given x and the f of x, and from that you learn the f of x, and given data you have to look at what is the g of x, and you have to do such that f of x minus g of x the whole mean squared is the least, error is the least. So, this is a well defined code, and g of x, if you are get a good approximation, you should be quite happy, and this is the method accuracy, root mean square error. These are methods in which the learning coefficient is measured. So, this is the training data set, this is the test data set. In unsupervised learning, however, you have the training data set, but you do not have the values. This just says that this belongs to the class, this does not belong to the class, same as before. For example, supervised is told, here in unsupervised this is not told. So, you are given a new data set, you have to find the model. Now, why is this very important? Because when you have large data sets, in order to actually tag that is a human manual work, and that takes a lot of time. So, that is why unsupervised becomes very important. So, you are trying to find whether there is a function that fits the data. On the other hand, there you are given this is the function, and I mean the label data, you can learn the function, and from that you will get this. So, if you compare supervised and unsupervised, here this is a true function, here it is a true model. Label data set, of course, this is unlabeled data set. So, here you are given the data and the function, here you are given only the data. You have to learn a g of x model trained to predict these labels, and the goal is to make this the least. So, here what is it that you learn? Again here you put some criterion, and according to that threshold you do that. So, classification example. So, example of the training database, look at this, two predictor attributes. So, age and car type. So, car type can be sport, minivan and truck, and age is ordered, car type is a categorical attribute, that means it can have 3 values, and class label indicates whether person bought or did not buy. So, you are going to classify this set of data into yes or no, whether they bought it or they did not buy it, and the dependent attribute is the category wise. So, this is an example of a classification. So, what we are trying to do is, given these two attributes, you are trying to predict the class. Now, let us take a regression example. So, you have this, and spent indicates how much person spent during a recent visit to the website, and the dependent attribute here is numerical. Let us look at some definitions. Random variables x1 to sk are the predictor variables, and there will be one dependent variable among other than that. Xi has a domain of xi and y has dom y. So, the probability distribution on this combination of these domains is what we are trying to find, and the training database D is a random sample from this probability, that is what we are assuming. So, a predictor D is a function which tries to predict, given these values, what is y. So, if y is categorical, the problem is a classification problem, and we use C instead of y. So, look at this here we use yes and no. So, it is just categorical, here it is not, it is numerical. So, C is a class label and D is called the classifier. Take R be the record randomly drawn from P, and then you have the misclassification rate. So, given a data set that is a random sample from the probability distribution, you find a classifier that minimizes the error. On the other hand, regression problem, the y is numerical. So, remember that example again, this y is numerical, and so this is a regression problem. It is also called the dependent variable, and D is called the regression function. So, otherwise it is the same, the way you do it is different, one is classification and one is regression. So, what are the goals and requirements to produce an accurate classifier or regression function, and to understand the structure of the problem, and requirements is high accuracy is needed. You should not even, as far as possible, even one prediction you should not do wrong. It is and what you predict should be the model should be understandable by humans and interpretable, and it should be very constructed very fast given the data. So, when you talk about classifiers, there are very different types of classifiers. I am just going to mention the names, and I am going to talk about one. So, linear discriminant analysis, quadratic discriminant analysis, density estimation methods, nearest neighbor methods, logistic regression, neural networks, fuzzy set, decision trees. This decision trees is what we are going to talk about. So, decision trees, what are decision trees? So, now let us take that example before, this example, and what we are going to do is, if the age is 20, okay. Now, take 20, you have 1, 2, 3, 20. In 20, you have M, T and S, all the 3 you have, and then 20 M you have yes, 20 T you have no, and 20 S you have no. So, that is what you are trying to represent here. So, let us look at that. So, age is less than 30, car type is minivan yes, sports and truck no, greater than or equal to 30 yes, that means that point of time it can be anything. Let us look at this. Greater than 30, 40 and 40, it can be, there is only 1, 2 40s, 40 it is sports and minivan, and so it is an S. Now, less than 30, so all this comes under less than 30, he can buy any of this and so on. So, you can draw the table depending on this, that is very easy to draw. You have to choose properly and draw again. Okay. So, here the important part is you should not have the depth of the tree should not go very high. So, the common variables you should do. Decision tree encodes D, a classifier regression function in the form of a tree. A node T in T without children is called a leaf node, and otherwise it is called an internal node. Internal node has an associate of splitting the predicate. Most open are binary. For example, age is less than 20 is 1 and age is greater than 20 is 1. So, profession in student teacher and the salary will be so much. So, it is not necessary it should be binary, but you can put it as binary. Anything can be converted into binary. Okay. So, for example, binary univariate splits numerical are ordered, x is less than or equal to c and c is in domain of x. Category also you can do like this. Linear combination split on numerical variables also you can have, or you can have a k-nary split also, it is not wrong, but generally they do it as binary. Leaf nodes, if you consider, for a classification problem, it will give you the class that belongs to DOM C. In the case of regression, there are two choices. T is labeled with a constant y in the domain of y, or it is given by a line or a prediction like a linear model, a straight line. Now, let us look at the encoded information. What does this decision tree tell you? If the age is less than 30 and the car type is minivan, then yes, that means he will yes, we had yes and no as category, whether he will do something. So, this is yes. If the car type is sports or truck, it is no. Okay. Now, if the age is less than 30 and car type is sports or truck, then no. If age is greater than or equal to 30, then it is a no. So, this is what we are trying to say. So, we looked at classification and regression as two problems that are sort of sisters of each other. Then we look at what is clustering. So, clustering is as we already saw and I explained to you is unsupervised. So, you are given only the data set, you are not given any label data and some similarity measure, distance measure or some information has to be used in order to separate the data. So, you have basically partition the data if they are dissimilar and group them together if they are similar. So, how do you define similarity? For example, groups of similar customers, you can group them according to lot of parameters. One is demographics, they stay in the same area, buying behavior, they buy lots of things, or the similar health conditions. Similar products, for example, you can have similar cost, similar function, similar store and so on. So, similarity usually is domain or problem specific. This is where the domain expert will come into the picture in data mining. So, distance between records, how do you decide? So, Dbm is a vector space representation. For example, R1 is this, R2 is this and Rn is this. Now, how do you find the distance between these two? Please note it is some dimensional space. So, it is a vector. What you do is you can have no dim similarity, you can find the distance between two vectors, and if distance is near 0 means near, infinity means far and so on. So, this is a way in which distance and similarity, if they are near each other, similarity will be good, if they are far away from each other, similarity will be bad. See, remember distance is the vector, distance between the two vectors represented this way. So, a data set of n records, each given an d-dimensional data feature vector. The output is a partitioning of the data set into a number of clusters and noise. High similarity records within each cluster, this is very important. For clustering, we have to look at what is called as intra-cluster similarity and inter-cluster similarity. The meaning of this is, if you have two data coming in the same cluster, then within that cluster the similarity should be very high, and if the two data comes in different clusters, then the similarity between the two clusters should be very low. So, this is the basis of clustering, and there are sometimes two types of clustering called hard clustering and soft clustering. This means that each object or data object can be, remember the data object is a vector, it is not an object, it can be only in one and only one cluster. So, depending upon the similarity, you will put it only, suppose it is similar to two clusters, then you do not put it, you put it only in one cluster. So, other than that, in soft clustering what you do, the probability of it going to this cluster and the probability of it going to another cluster. So, it can be in two clusters or three clusters or whatever it is. So, this is type of clustering. There are many types of clustering algorithms, again I am just going to mention this. So, the partition based clustering, Kmeans clustering. Kmeans clustering means you take a set of say take two data, find out if they are similar, if they are similar above a threshold, put them in the same cluster. Now, this you do not take the vector of these two, you combine the two and take the vector of that, or the centroid and so on. So, that is K-means. You can also do agglomerative clustering, and density based on the density of the points. So, we are not going to go into do this. So, K-means clustering alone will initialize cluster centers, assign each data point to a closest cluster center and recompute the cluster center. That is what I said, cluster center is the centroid, and while there are still changes you keep doing this till it normalizes. So, here you do not know the number of clusters. Okay. So, why does it work? How does it find the cluster centers? Does it find optimal clustering? What are good starting points? What is the right number of clusters? How do we know it will terminate? This depends very much on the data set, depends on what technique you use to find each of this. So, this is a research issue and it is still worked on. Advantages: it is good for exploratory data analysis, works well when the dimension of the data is not very high and it is reasonably scalable. How many ever records you have you can do, but the problem is, suppose you want K means how to choose a K, that is very important, and sometimes clusters are not it does not fit like that. Next we go to agglomerative clustering. Here what you do, put each item in its own cluster, that is initially suppose you have 1 lakh data items, each of them is considered to be in a cluster, that is 1 lakh, and you keep merging it till it works. This is how it look like. And you can also have density based clustering, the more dense it is the more you cluster it. Next is a important concept called market basket analysis. So, you consider shopping market filled with several items. Market basket analysis tries to answer who makes purchases, what do customers buy together. So, if I buy bread I am likely to buy butter and cheese, if I buy milk I am likely to buy coffee or something like that, and also in what order customers purchase, that is if they do it yesterday what are they likely to do today. So, this is a important aspect in many of the business applications. So, this has been given a separate type of analysis called market basket analysis. Typically, you explain market basket analysis with customer databases. So, database of customer transaction is given here and each transaction is a set of items. So, for example, all these 4 are, so he buys pen, ink, milk and juice, and what is the quantity he buys. So, 80% of all customers buy purchase items X, Y and Z together. 60% of all customers who, this is what is called as co-occurrence. Association is 60% of all customers who purchase X and Y also buy Z. 60% of customers who first buy X also purchase Y within the 3 weeks. This is typical patterns you can get, and for each pattern you have what is called a confidence of a rule, support of a rule. So, confidence of a rule means given X, what is the probability that Y will occur and with what confidence, this is probability. So, number of times X occurred, and at that time how many times Y occurred, and X is Y has support X is if these two together have a support of this. So, this is usually used to do the analysis, and this is another example. For example, pen, milk, support is 75, confidence is 75 and so on. So, sample application you can use it for direct marketing, for fraud detection, for flow shelf planning, so that people buy it together, website layout, cross selling. Applications, this frequent sets is very important, there are a lot of algorithms to do this, market association rules, classification, seeds for construction, web log analysis, collaborative filtering. So, here we have explained data mining and the need for it, discussed data mining process, explained different techniques, though we touched upon only some decision tree, clustering, regression model, K-means and so on, discuss some clustering techniques, and we just touched upon what is market basket analysis. So, I want you to answer the following question: what is data mining? Explain with an example, take an example, not the one that we discussed. Discuss the different issues associated with the data mining, what are the parameters that you have to consider, and what is the basic difference between supervised and unsupervised. Do this with an example. Simply explain regression model and decision trees with an example. Discuss market basket analysis with an example taken from the student database. Now, in the student database, basically market basket is for transactions. So, what do you think will be in the student database, what do you think will be the transactions? Then these are 2 exercises I want you to do. Find all sets with support greater than 75. Can you find all association rule with support greater than 50% for this example? Thank you.